Okay, the tower crane is used to hoist a 2 megagram load upward at constant velocity. The 1.5 megagram jib BD and 0.5 megagram jib BC have centers of mass at G1 and G2 respectively. Determine the required mass of the counterweight C so that the resultant moment produced by the load and the weight of the tower crane jibs about point A is 0. Okay, the center of mass for the counterweight is located at G3. Okay, so this is a very good question because it's a problem from real life. So we are having a tower crane here, which is mostly used in construction sites. So this is used to hoist a 2 megagram load upward at constant velocity. So this is our load. This is our 2 megagram load, right? And so it's got a constant downward effect of this load. We have a downward effect of this load. The 1.5 megagram jib BD. So this is jib BD. So we're talking about this jib. So this is jib. Okay, let's use our black pen here. So this is jib BD, and the other jib, this one at the back, that's called the jib. So this is jib BC. Okay, what else? So the center of mass for jib BD is here at G1, so we have like a weight of this jib downward, and the center of mass for jib BC is here, so we have a downward effect here. Okay, and we have another weight here, another mass here, affecting downwards. So basically, the question is asking us like mass of counterweight C, mass of counterweight at C. The counterweights are used to balance these two jibs and the tower itself under the effect of this load that is being carried by the longer jib. So we need a counterweight at the back end of the tower. So let's write down some values here. So mass of jib BD is equal to 1.5 megagrams. Mass of jib BC equals 0.5 megagrams, and we have our weight here, 2 megagram of load. So we have 2 megagram, 1.5 megagram, 0.5 megagram weights acting downwards. So 2 here, 1.5 here, 1.5 megagram here, and 0.5 megagram here. So what's that? So for equilibrium, we need to satisfy equilibrium moment around A. So these forces are causing moments. So the forces on the right hand side of the tower and the left hand side of the tower, they are trying to rotate. So on the right hand side, forces are trying to rotate the tower around B in a clockwise direction, while on the other hand the weights of the left hand side are trying to rotate the tower around point A. So we need a balance, we need equilibrium for this. So as for the solution, okay, so solution is very simple and very short. We simply write down, so resultant moment, we need to find the resultant moment around point A, and assuming that counterclockwise would be positive, so we have like sum of force times these, so these are moments of each acting forces, so the sum of all these moments, it should be equal to 0. So for equilibrium. Okay, so let's write down some equations now. So we have 0 is equal to, let's call this mass C. We're trying to find mass C. So we need to multiply this by 9.81, which is G. So that's weight. Weight of our counterbalance weight at C. So that's acting on counterclockwise, so that's positive. We have the weight of the jib on the left hand side, so this jib is 0.5, so that would be equal to 500 times 9.81. So these are all masses. So we need to multiply all these mass values by gravitational acceleration to get to have weights calculated. So times the moment r, this 4 here. Let's come back and check. So this is our moment r here, 0.4 meter around A, around an axis, that's the axis passing through A. So that's the, okay. And for the forces acting on the right hand side of the tower will be the force, the weight of the jib, the BD, 9.81, so the weight of jib BD, weight of jib BD, this is weight of jib BC, and that's weight like for the balancing weight at point C. Okay, and minus our load that is being lifted up. So 2000 times 9.81, so that's the weight of the load, and then times 12.5. Oh, sorry, I forgot to write here the distance. So the distance for G is 9.5, G1 for the GBD. Okay, so for this we need to write 9.5 here, and this is all equal to 0. So solving this equation, we get mass of C will be equal to 4966.7 kilogram, and that is equal to 4.97 megagram. Okay, and that is the answer for our question. Okay, Thank you.